right angle. So orthogonal is just another word for perpendicular. You know about parallel, you know about perpendicular. We'll talk about that later on. Okay, so number 34 is our first example. So I'm going to erase my diagram so we can leave the formula up here. So 34 is going to give you a vector V and a vector W. And we're just going to have to get through the math part. We are relating this a little bit to physics, but most of it's just the math part. So this is given. They're going to give you vector V and they're going to give you vector W. That's the given information. So we're going to use the formula, okay? We're going to use the formula. And the formula is going to say the dot product, we'll do the top part, the dot product of vector V and vector W. So somebody tell me really quick, that for those of you that did your homework, how do I find the dot product of V times W? We're doing this part first. You multiply 3 times 2 because those are the coefficients of your I components. And then you multiply the coefficients of your J components, and then you combine those two products. Okay, you may have a positive plus a negative or a negative plus a negative. You're just going to combine those. Then the bottom part of that formula you already know how to do. The double bars mean magnitude. So can y'all find the magnitude of vector W in your head? Radical 5. And so that formula says that's going to be radical 5 squared. Then the formula says we're going to multiply that times vector W. Okay? So that would be times 2I plus J. So we're just doing the math part here. So 3 times 2 plus negative 2 times 1, that would be 6 plus negative 2. So that would be 4. And the square root of 5 squared is 5. So I just simplified that. And now I'm going to multiply times 2I plus J, vector W. And that would give me 8/5 I plus 4/5 J. And that becomes your vector sub 1. Because back in the formula, this is what you're actually finding. You're finding your V sub 1. So the 8/5 I plus the 4/5 J is your V sub 1. So again, the directions say find V sub 1, then decompose V into 2 vectors, V sub 1 and V sub 2, where V sub 1 is parallel to W and V sub 2 is orthogonal to W. You're just using the formula to find V sub 1 and V sub 2. We don't have a lot of time right now, but we'll talk a little bit more about how this is used tomorrow. So V sub 2, here's the formula for V sub 2. It's just the original vector V minus V sub 1. Okay, so I'll try to erase so we can get this. So if we're finding V sub 2, we're doing the original vector V minus the V sub 1 that we just found. So the original vector V, I erased it, but it was 3I minus 2J. And then you're subtracting the vector that you just found, which was the 8/5 plus the 4/5. So 3 minus 8/5, you can do that in your calculator. That is 7/5. And negative 2 minus 4/5, that'd be the same as negative 10/5. minus 4/5, that would be negative 14/5. So they want you to find v sub 1, and they want you to find v sub 2. That's what you're doing in that set of directions. All right, you try 38 on your own, okay? You try number 38 on your own. I'll give you the original vectors. So for 38, if you're not looking at your book, vector v is 2I plus j. And vector w is 6I plus 3j. So you're doing number 38. Vector v is 2I plus j. Vector w is 6I plus 3j. Doing the same thing I just did with 34. You've got the formulas. You just have to go through the math part of the formulas. You're finding v sub 1 and v sub 2. Give you a couple minutes to do that one. An example of a situation where you would use this formula is if a car was driving downhill, okay, there's going to be a force of gravity, and then there's also going to be the force of the rate that the car is traveling. So projection vectors always have the same direction. And everything that we did in 6-6, we had those two tugboats pulling in opposite directions. Okay, or we had a handle on a wagon being pulled at an opposite direction as that horizontal vector. So there are some problems, and we're not going to do any word problems in this section. Okay, you're just going to have enough to do the math part of the formulas. We'll let physics teachers teach physics, and we'll let math teachers teach math. Sometimes Miss McLean comes and asks me about math stuff, and I go and ask her about how do you draw this, or was Miss Bates a chemist? She was a chemist. She was a what? Have any of you got into this section on the website?
Okay, so explain how y'all are doing it because it doesn't add up with the first one. So you got 6 minus 2 is 4. That's where she got the 4. She's not doing it.
All right. So what'd y'all get for v sub 1? 2I plus j. And for Yeah, v sub 2 is going to be v minus v sub 1. So that's going to be 2i plus j minus 2i plus j. So that's going to give you 0. Anybody have a question about that one? All right, so in the next section, they're just going to let you do some operations with vectors, and they're going to give you 3 vectors. So the next section's going to change. The directions are going to change. These will be what you do for 39 through 42, and they'll give you 3 vectors. And here we're really just doing operations. There won't be any formulas. We'll just really using our math skills here. So they're giving us U and V and W. People make dot products so hard, and it's because you never read the notes to begin with. It's not hard at all, just different. I had somebody take the ACT once, and they came back and they said, man, there was a lot of calculus on the ACT. And I kind of looked at them really funny. I said, no, that's probably algebra 2 or a tiny bit of trig, and you just didn't know what you were doing, and it looked like calculus to you. All right, so I would give you a little bit of a caution on vector W, and why might I give you a little bit of caution on vector W? It doesn't have an I, okay? So if you wanted to write it, 0i minus 5j, if you don't write it, 0i minus 5j, you need to think that, because you're going to start to do some operations, and you're going to mess up because you're not going to think that the coefficient of the I component of that vector is 0. And they're just going to throw all kinds of little operations in. So we're going to do number 40 as an example, and this is what the problems look like in this section. 4u dot 5v minus 3w. And you'll do order of operations. And this one is just math. It just happens to have some vectors in it. So you're just actually using math here. So you're going to do what's inside the parentheses first, and then what's inside the parentheses first is you got to multiply by the 5 and the 3 before you can subtract. So you could go ahead and do your 4u. That'd be negative 4i plus 4j. And this dot it means something different. That's your dot product. Doesn't mean just multiply. So 5v would be what? I minus 10j, and then you're going to subtract 3w, which is negative 15j. So you'll get a vector there. And that's going to give you, if I do the bracket, I get 15i plus 5j. Everybody with me that far? And then you just apply the dot product. And the dot product says multiply the coefficients of the i's and combine that by the product of the coefficients of the j's. So you can either do that in your head, or you can show your work. So you're just doing negative 4 times 15, which is negative 60. There are no variables in the dot product. A lot of people try to put variables there. So negative 4 times 15 is negative 60. And then we're combining that with the product of your j coefficients, which is 20. And then your final answer is negative 40. All right, And then the last part of your homework, I'm going to just show you a mathematical shortcut. They're giving you this whole long vector dot product stuff. So if it's okay with you, I'm going to show you. You want me to go back? I'm going to show you something that you learned in 8th grade, maybe 9th grade. Everybody got that? Alright, so for 45 through 50, they're asking you to determine whether the vectors are orthogonal, parallel, or neither. Okay? They're asking you to determine whether the vectors are orthogonal. So let's talk about orthogonal vectors. Orthogonal vectors are two vectors that form a 90-degree angle. When we talk about vectors, they don't use perpendicular, they use the term orthogonal. And they're going to ask you to use dot product and a formula for these, and I'm just going to show you how to use slope, because you already know about slope. If two vectors are parallel, they could actually look two different ways. Okay? If vectors are parallel, they have the same direction. Now we're talking about two vectors that actually have the same endpoint. So the vectors could look like my first example, or we could have a projection vector here. So I could have case number 1, or I could have case number 2. So what they want you to do is they want you to go out and find the angles. Okay? So the angle formed here would be 90 degrees. The angle formed here between the two vectors would be 180 degrees, and then the angle formed by case number 2 would be 0 degrees. So what they're teaching you to do is they're teaching you how to take a formula and find the angle formed by the two vectors. Well, couldn't you just draw the vectors and determine whether they form a 90-degree angle if you put them on a graph? Okay? Couldn't you just draw and see if they look like the first 180 degrees or the second one? So a couple different things that you could do easier than what they're asking you to do is you could actually draw the vectors. You could draw them. But to me, even easier than drawing, you could calculate slope. You could just calculate the slope. So let me remind you that if something is perpendicular or orthogonal, then the slopes are opposite reciprocals. Forgot how to spell all of a sudden. So if orthogonal means perpendicular, then your slopes are going to be opposite reciprocals. If your vectors are parallel, then your slopes are going to be exactly the same. So the formula is not hard to find the angle between two vectors, but it's a lot simpler for you just to do slope because it's something mathematically that you already know how to do. So I would suggest in this section for you just to understand that orthogonal means perpendicular and just understand that parallel vectors mean parallel. Orthogonal vectors would have slopes that are opposite reciprocals. Parallel vectors would have slopes that are the same. Okay? So I'm going to kind of go against mathematically how they're asking y'all to do these. So if they give you these two vectors and they say, are they orthogonal, parallel, or neither? Hi.
Can I see a couple people real fast?
Sure, you can see.
I need to see Mary Arlen, Thomas, Sarah Grace, Harriet, and Cole. And anybody else in this room is signed up to take AP Biology. 2 seconds.
Anybody else? So, if you think about graphing vector V, you would go to the left 2 and up 3, right? So if you go to the left 2 and up 3, what would be the slope of vector V? So if you needed a visual here, what would be the slope of this vector? Rise over run. What's the slope of that vector? Negative 3/2? Okay. Alright, so let's make a connection. If we're doing slope, it's y over x. In this situation, it's going to be j over I, because y and j are the same when we're graphing. I and x are the same. So what's the slope of vector w? It would be 9 over negative 6, which reduces to be negative 3/2. So if I were to graph the vector negative 6 and 9, it would be parallel. Okay? So it's just a lot quicker just to do slope here. You get exactly the answers that you're supposed to. So for number 46, you're going to say parallel because we found the slope of both vectors and they were the same. So all you really have to do is find the slope. So when you find the slope of a vector, you're doing the j component divided by the x component because that's your y over your x. If you graphed it, you would see what we're doing here. All right, so 48. Gives you vector v is negative 2i plus 3j. Vector w is negative 6i minus 9j. Shh. So the slope of vector v would be negative 3/2. And the slope of vector w would be positive 3/2. They're kind of trying to trick you there because one's positive and one's negative, and they're trying to trick you into the fact that those vectors are perpendicular. But remember, one's got to be negative, one's got to be positive, and they have to be reciprocals. So that these slopes aren't the same, so the vectors are not parallel, they're not opposite reciprocals, so they're not orthogonal. This will be an example of neither. So if you want to use their dot product formula that they have, you can to find the angle between the two vectors. If you want to graph the vectors to see what they look like, you could graph the vectors, or you could just use slope. So the last one is number 50. I have one of each situation. So in 50, vector v is negative 2i plus 3j. So the slope of vector v would be what? Negative 3/2. W is negative 6i minus 4j. So the slope of vector w would be negative 4 over negative 6, which reduces to be positive 2/3. So a negative 3/2 slope and a positive 2/3 slopes are opposite reciprocal, so that would mean that those two vectors would intersect to form a right angle, and so in this section those are called orthogonal. Now what I need from you is if you